Hey guys, this is Dr. Mo with the third and final Geometry Dash video. By the time you're done with this, you should hopefully have a game that is able to have at least this level of functionality, and then I'd like you guys to add a few more bells and whistles. So, as you can see here, the final form of my game has a player that spins when... Oop, he dies also. Collision still works. I have a player that spins when he jumps, whenever he's not on the ground or on a platform. We do have platform collision. We have collision with both downward pointing and upward pointing spikes. We also have sort of kind of levels. So what's going to happen right here is the map's going to start over again, and not only do the colors change, but oops, it's sped up a little bit. Okay, and so it gets harder and harder the more you play. So it's kind of cheating in terms of levels. It's not really a brand new level. It's the same thing, just going a little bit faster. A little bug here you can see right there. You can, if you jump sideways into a platform, you can kind of phase through it like that. I don't have a problem with that, but if it really bugs you, let me know and we can talk about it in class how to fix it. Lives aren't set up yet. That's something I expect you to do. Music and sounds and maybe some flashier sound effects would be great. Lives still aren't working. You can see there's no information on the screen in terms of like my score or my lives left or even what level I'm in, that kind of thing. But, I mean, the basics of the game are ready to roll here, and the rest will be up to you to finish up. Okay? So, here we go. Let's talk about it. So, map, I'm not going to spend that much time on because, I mean, you guys have done this before with Pac-Man and other 2D games that use a 2D matrix, 2D array. We've just added different numbers that represent the different things in the game. So you can see here like a platform with downward spikes, facing spikes, etc. The function, the collision function, the declaration hasn't changed, but the definition has changed in order to handle platforms and the downward facing spikes. We did add a couple new variables here. Lives, I think, was already there, but it's not really doing anything. It would be really easy to have your game loop run on lives, and as soon as you're out of lives, the game quits and does some sort of closing screen. Level is what is increasing the speed and changing the colors every time we re-loop the map. And then this angle has to do with how we spin the player, and we'll talk about that more in the render section in just a little bit. Okay, we did get rid of the variable that was like can jump again or something like that. It's not that we have double jumping at this point, but if you watch the character, he can kind of like float really. It's still plenty hard. But he can float a little bit better now to make it at least not impossible. Before I messed with the jumping function, it was pretty much impossible to win the game because you had no control as to how high he jumped or how long he was in the air or something like that. And this just makes it playable, at least a little bit more playable. Okay, I don't think there's anything new until we get to the timer section because that's where most of the physics happens again. Okay, so we already had map scrolling, but a change that I did add is that every time we re-loop the map, I'm increasing this variable called level, and then that level is being added to the map offset. So remember, this is the line that actually controls the speed of your looping, and right now the speed is set to be 3, and by the first time through the game, this is set to be 0, so the whole first time through the map is going at a speed of 3 pixels. But every time we add another number to it, and by like the 5th level you're moving at a speed of whatever 5 plus 3 is, 8 pixels. Which doesn't sound like a lot, but it actually does move pretty fast. Okay, here this overall isn't anything new other than the fact that I'm having it bump up the angle or stop the angle. Let me take a break and zip down to the render section so I can talk about how that angle actually impacts the character being drawn, and then we'll move back up and talk a little bit more physics. So here's my render section. You can see the map being drawn. I always draw my player after the map because otherwise he'll like go behind platforms, maybe you want to do that, but I think that would look weird right now. Here's the old function that was just drawing a plain square, always facing upward. I replaced it with a function called draw rotated bitmap, which is exactly what it sounds like. It spins your bitmap. If you hover over it, it'll show you the parameters it expects. The first thing it wants is an actual bitmap. We're just using like a pre-drawn square, not a primitive square, but like a bitmap square. You can still upload anything you want, you know, a actual picture from a character from Geometry Dash or your friend's face or whatever you want to do. Okay. These two variables, this X and Y position, is the point around which you spin. So I wanted to spin in the middle of the square that was being drawn. When I first did this, I forgot the plus 16 and it was spinning around the top left corner and it was really weird looking. I actually recommend messing with this and breaking it just so you can kind of see the different ways it works. This here is the point on the picture that is kind of like the central spinning point, kind of like a fidget spinner. This is like the middle of it. And again, I'm setting it to the middle of this square because the square is 32 by 32, so the middle point is 16 by 16. This is how much you spin by, okay? So if you never increase this number, it's not going to spin. It's going to act and look exactly like this old function. So up here, when we're looking at whether or not we're on the ground or in the air is when I'm actually impacting that angle. So anytime I'm on the ground, like right here, this is when I'm actually on the ground, the bottom of the screen, I'm not spinning. Anytime I'm on a platform, I'm not spinning, the same way I'm not falling anymore on the ground or on a platform. However, every other time, if I'm up in the air, which is right here, I am spinning. And this spin is pretty fast. Notice I'm just adding like a 0.25 here. That's one of the reasons why we used a double instead of an integer, so we can handle these decimals. Go ahead and mess with this. If you, I had it out like 1 for a while and it was really frantic, but you're welcome to mess with that and just kind of see what it looks like. All right, a couple other concepts to go over here real fast. So I did get rid of the variable that stopped me from, it's not like a double jump. It's just, basically what I'm saying is if you look down here, I put this piece in instead of looking at have I jumped recently. I'm just basically asking like, hey, have I let go of my up key? You're going to not have any gravity as long as you don't lift up the up key. Okay? So keys up equals false. So as long as you hold down that up key, you're going to be spinning. But as soon as you let go, bam, that's when gravity starts to pull you back down. So it's not really double jumping. It's not really flying. I don't really know how to describe it. It's just kind of like, kind of feels like maybe you have a jetpack on or something, and as soon as you let go of the trigger, you start falling. But I think it works pretty well for the physics of this game. There's lots of other ways you can do this. You could put in a double jump. You could stop it from being able to hover like this if that bothers you. I don't think it makes the game really that much easier, so I'm just going to leave it in there. But talk to me if you want to mess with the physics and we could play around with it. Or even better, you mess with it. Derpy explosion graphic we already went through. I think that's it in terms of the other changes. So we talked about the change in the jump. So I guess the only thing... Oh, here you can see me drawing other stuff. Can't remember if we already went over that. That's a lot of stuff there. Sorry. But basically, drawing the bottom triangles are the same thing, other than the fact the downward facing ones are pretty much the same, other than the fact that sometimes you're adding 15, sometimes you're subtracting different numbers. Play around with the numbers. I'm not going to be very helpful. I don't want to be very helpful with this because I really want you to think about the math to get things to look right. So just trial and error if you need to. Okay? Last thing is I want to talk about the alterations I made to the collision function. So number one is, and I should have done this in the last video, but I changed it so the collision function is only checking for collision within the bounds of my 2D, my 2D array. If our offset is bigger than 3000 or less than 100 as it is when we first start, or as it is before the map, right when the map ends and it's about to rotate over again, we're basically, if you don't do this, this is going to be looking into nonsense areas of your grid. Like, let's say you're at 3,200 and you try to add that here and then add another 30 and then add X and divide by 30. Even after dividing by 30, you're going to be off the edge of the map. And I'm surprised actually that it didn't crash my code before when we did this, because you're pulling garbage values. You're looking somewhere in RAM that doesn't belong to our program and checking to see what's in there, and who knows what the heck it is. But I was getting these weird, like, ghost platforms and ghost triangles that I was landing on and getting killed by that I didn't see, and it's because I was looking in garbage slots. So right away, this collision function quits. It kills itself. Not the whole game, just this function, by returning 0, no collision, if I'm not really looking at my map during those blank periods between the levels. Okay? I did add a second part here, so you've seen this part already. What I did is I added an OR statement. I said, hey, if I run into an upside down triangle, sorry, a right side up triangle, which is the 1, or an upside down triangle, which is a 2, go ahead and return 1. That means we've collided against a triangle and we've died. Okay? The platform is a little bit more complicated. And this one has an OR not because I'm checking for 2 different types of things. This one has an OR because I'm checking both his left-hand bottom corner and his right-hand bottom corner, kind of like we did with Pac-Man. Because you don't want to be in a situation where you land halfway on it and you go through it because you're only checking the other corner. Okay? So with this guy right here, the plus 30 means I'm checking the bottom part of my square, not the top part, because remember Y is at the top part. Okay? Here I'm checking the right-hand side plus my offset, so I'm actually like looking at the map. I'm dividing by 30 in both places because that's how wide my grid lines are in my map. And then this is checking the left-hand side. Right-hand side, I added 30 to my X. Left-hand side, I don't check anything. Okay? So if you took this out, if you only checked this part right here, it's quite possible if you land halfway through on the far side of the platform, you'd fall right through. So just like the other check, I did add 30, so we're still checking the bottom. And then right here, I'm checking the left-hand side, directly below the top left corner. Okay? So if either of those are returning a 3, it means that we are about to land on a platform, and we return a 2. Up here in the timer section, we are checking at one point. We call the collision function a second time. Okay, so here's my original call. Wait, I think it's up here, sorry. Probably would have made sense to put these right next to each other, but of course I didn't do that. This is what you call spaghetti code. Kind of all over the place. There we go. So this you had already seen from the previous game. So if your collision function poops out a 1, it means you've collided with a triangle and you need to do all this fancy stuff. You need to display the explosion graphic, you need to subtract from lives, you need to reset your player's position, and you need to reset the map offset. Over here with this one, here we go. If the collision function poops out a 2 instead of a 1, that means you've hit a platform instead of a triangle. So instead of killing the player, we're going to say, hey, you're on solid ground now, so gravity doesn't have to work anymore on you. We're going to stop that angle so you're not like spinning through the platform. And we're also going to set your Y velocity, like reset that to 0. So this stops you from falling, and this stops gravity from starting you falling again until you're off that platform. Okay? I think that just about covers it. You don't have to be crystal clear on this. You're welcome to ask me questions, but it should enable you to get to this point. And in the actual project assignment for this guy, if you're doing it as a project and not just, curiosity and kind of doing your own thing and using pieces of this to make something else, but if you're actually doing you're doing this game as one of the projects for my class, I will outline a few changes that I definitely would like to see, including a opening splash screen, closing